You think you understand gravity. You stand on the ground. You feel your weight. You drop something. It falls. Everything seems to be pulled downward by some invisible force. Simple. But here's the problem. That idea is completely wrong. Stop for a moment. Right now, feel your feet. That pressure, that force. You call it gravity. But think carefully. What are you actually feeling? It's not a pull. It's a push. The ground is pushing up against you. That's the only thing you've ever felt. Not once in your life have you felt gravity pulling you down. Not once. Now try this. Jump. For a brief moment, that pressure disappears. You feel weightless, almost like floating. But wait, if gravity is constantly pulling you down, why don't you feel it more when you're in the air? Why does it feel like nothing at all? That's your first clue. Something about our understanding is off. Now look at the moon. It orbits the Earth, calm and steady. But what is it really doing? It's falling. Right now, the moon is falling toward Earth. That sounds wrong, doesn't it? Because it never crashes. It never gets closer. It just keeps circling. So what kind of force pulls something forever, but never pulls it in? And here's an even stranger question. How does Earth pull the moon at all? There's nothing between them. No rope, no contact, just empty space. This is where Isaac Newton comes in. He described gravity as a force between masses, and his equations worked beautifully. They explained planets, orbits, falling objects, everything. But even Newton admitted something uncomfortable. He didn't know how gravity actually worked. He called it action at a distance, which basically means something is happening, but we don't know how. For a long time, people accepted that because the math worked. And when the math works, people stop asking questions. But maybe they shouldn't have, because there's a deeper problem. Think about motion. If something is moving, it keeps moving. That's the natural state. Objects don't need a force to keep going. They need a force to change direction. So why do planets move in curves? Why don't they just fly off in straight lines? Newton said, because gravity pulls them. Sounds reasonable. But again, what is that pull? This is where Albert Einstein changed everything. He asked a different question. What if gravity isn't a force at all? Imagine this. You're inside a closed room. You feel your weight pressing you to the floor. Are you standing on Earth, or are you inside a rocket accelerating upward? You can't tell the difference. Every experiment gives the same result. This is the key insight. Gravity and acceleration are indistinguishable. And from that comes a shocking conclusion. Gravity is not a force. It's the shape of space itself. Think of space like a stretched sheet. Place a heavy object on it. It bends. Now place a smaller object nearby. It doesn't move in a straight line anymore. It follows the curve. That's exactly what's happening in reality. Mass bends space, and objects simply follow the curved paths. You're not being pulled toward Earth. You're following the straightest possible path in a curved space. So why are you standing still? Because the ground is stopping you. It's pushing you upward, preventing you from following your natural path. That push is what you feel as weight. And when you jump, the push disappears. You're finally free. Free to follow your natural motion, which means something incredible. Falling is natural. Standing still is not. Now everything makes sense. The moon isn't being pulled. It's following a curved path around Earth. Planets aren't controlled by a force. They're moving through warped space. Everything connects. Gravity isn't pulling things together. Space is guiding their motion. So next time you stand on the ground, remember this. You're not being pulled down. You're trying to fall. And the earth is in your way. Gravity isn't a force. It's the shape of reality itself.